Alright, here's solutions to perfect problem 5. In this problem, we're just given a single point here, 2, 3. So I suppose I could graph that point. 1, 2, 1, 2, 3. So we have this single point right here, and the idea is this point right here is on this function f of x. But other than this point, we don't know anything about f of x. But we do know some stuff about g of x. Actually, we know g of x in terms of f of x. So what we can do is our goal is to find one point on g of x, and the way we'll do that is by kind of tracking where this point right here goes when we do each of our different transformations changing f of x into g of x. So what I mean by that is there's kind of 4 transformations here, and if we can identify what each of them do and the proper order to do them all in, we can kind of think about where each transformation would take this point, and wherever we end up will be a point on g of x. So let's see, the only thing that's important is we actually have 3 vertical transformations, this negative right here, this 2 right here, and this plus 3, and 1 horizontal transformation. And the only thing that matters in terms of order is that we make sure we take care of all of our vertical stretches before our vertical shifts. So we have to make sure we take care of this negative 2 and this 3 before this plus 3. So maybe we'll first take care of this negative right here. What the negative on the outside of the function does is it flips over the x-axis. So if we used to have this point at 2, 3, you can kind of picture whatever function you want, but keep in mind we don't know the function, but we know this one point, if we kind of flip it down here, it will now land on 2, negative 3. Right, so if it was originally 2, 3, this negative right here, maybe I'll call this 1, takes it down to 2, negative 3, sort of moves it over there. Maybe I should change color. Okay, what about this 2 right here? We'll call this transformation 2. This 2 is a vertical stretch, so it stretches away from x-axis by a factor of 2. So really what it does is it multiplies all the heights, all the old heights by 2. So this point right here had a height negative 3. So if we're going to stretch that away from the x-axis, we're going to double that height. So from negative 3 it goes down to negative 6. So instead of this point being at 2, negative 3, it now moves down here to 2, negative 6. Okay, we've taken care of the 2 hardest ones. We have 2 left here. I guess I can change colors again. This third one here. Okay, now we're changing the x instead of the f of x, so this is going to be a horizontal transformation. Negative 5, it's kind of backwards of what you'd think. It moves to the right by 5. So this point right here that used to be at 2, negative 6 has to move right by 5. So the height will still be negative 6, but instead of its x-coordinate being 2, its x-coordinate is going to move all the way over to 7. So let's see, 3, 4, 5, 6, 7, something like that. So its new point is 7, negative 6. This what shifts right by 5. Alright, and finally, our 4th transformation here, this plus 3, all that does is it shifts our whole graph up by 3. So shifts up by 3. So if we used to be at, I guess I should keep my arrows going, color coordinated. So if we used to be at 7, negative 6, we want to move that up by 3. So instead of its height being negative 6, its new height goes up to negative 3 again. So if we do all 4 of these transformations, this point that used to be at 2, 3 is now at 7, negative 3. So 7, negative 3 is on g of x. And now we're halfway through. That answered the first question here. The second question says that, okay, if g of x is even, give me another point that's on g of x. Well, if it's even, it's symmetric across the y-axis here. So this point right here, when x equals -3, sorry, when x equals 7, the height is -3. So what we'd need is when the x equals -7, the height to still be -3. So 1, 2, 3, 4, 5, 6, 7. In order to be symmetric over the y-axis, if this point 7, -3, maybe I make that big, is on our graph, and this point over here at -7, -3 is also on our graph. So if even -7, -3 is on g of x. Finally, that's the answer to the solutions for this perfect problem.